We're going to take a look at an application of what's called the law of large numbers. So in order to do that, we're going to simulate tossing a coin 20 times, 40 times, and 80 times in Excel and look at the percentage of heads and percentage of tails and just try to see, what does anything happen as we increase basically the number of tosses. So we had previously done a simulated coin toss where we said, okay, cool, let's have our tosses. We counted those. And then we had our outcomes. We used the rand between function, and then our fixed outcome. Well, we just had gone through this rand between and copied our list and just made it fixed value so that it wasn't changing every time we did something here in Excel. And then we did the number of heads, and we even talked about how to look at that in terms of a percentage or change it to a decimal at the very least. So we're going to do the same kind of thing, but we're going to expand the number of tosses. So, there's, again, a couple ways to do this. If you want to stick in this sort of vertical sense, and we want to say, 20 tosses, and then compare this with, this doesn't need to be bold, we can say 40 tosses, and then we can say 80 tosses. And I will say that organization is going to be your friend on this. So if what we're interested in is comparing for each of those scenarios, the percentage of heads and percentage of tails, what we may want to do is just insert some extra space above here to actually focus on that those outcomes. So we can take information like this and we can say, well, I'm going to hit Control X and move that over here, Control V. I'm going to say, well, maybe not number of heads, but rather percentage of heads, and those are pretty small columns, so I'm just going to expand those a little bit. So percentage of heads, and let's say, well, we want this for each of the scenarios, so I'm going to say, okay, percentage of heads for each one. Of course, we can fill in for percentage of tails, but I think it's basically going to look the same. So I'm also going to get rid of those functions. We can come back to those and see in just a second. So for 20 tosses, right, we do want to use that rand between, and I'm actually going to use that bottom right, just hold down and pull it over so that now the first toss says rand between 0 and 1 for each of my 3 scenarios. So for 20 tosses, we actually already have that going down here to 20. Again, there's probably some other ways that you could do this, but if we're just staying vertical and kind of working off of what we had before, oh yeah, I should have mentioned, if you just take the last value and scroll, it doesn't do anything. But if you do 18, 19, 20, it understands the pattern. It'll go with you. So now we see it counting up. I'm going to go down until it says 80. Notice this is going to be past the 80th row here. That's because I didn't start at the very first row. So down to 80 tosses. So I'm going to use, for 40 tosses, my rand between. I'm going to go, okay, let's drag this thing down until I see 40. I went a little too far here. Okay, so there's 40. And then I'm going to take 80, and this one I can just see what happens if I double click that bottom part, and this should go all the way down to 80. So that's good. Okay, now what I'm going to do is because we know those rand between functions are going to change our values, I'm just going to highlight this, and I'm going to hit Control C. I'm going to copy it, and then I'm going to just paste those values right on top here, so that now if I click on these, it just tells me in the formula bar what the number is. It doesn't say rand between, so we don't have to worry about those changing. So if I say hi over here, hit enter, notice nothing changed. So those are all solid values. We're good to go. Okay, so the percentage of heads. Well, we know that to get the number of heads, we said we can use that COUNTIF function. Whoops. We can use that COUNTIF function and open up a parenthesis here and say, okay, let's count. Here's our range. So we're interested in this range. And I want to count all of the ones. The ones were heads for us, zeros were tails. So if we do that, hit enter, then this tells me, okay, there were 11 out of the 20 tosses that were heads. Well, that's just the number, not the percentage. So let me go back to my formula bar here and say, okay, let me divide by the number of tosses that I had. So let me divide by 20. And I'm going to get 0.55, this is, again, the decimal version. If you want the percentage version, there's a couple ways to do that. You could click on the percent up here and it'll turn it into 55%. You could also leave it. So I'm going to Control Z, I'm going to undo that. And you could just multiply this by 100. Right? Percent means per 100. So you could do that and you get 55. That's however you want to do it is totally fine. I honestly think probably leaving it as decimal is perfectly fine. Okay, and then I'm going to go, hey, wait a minute, maybe I can just take this formula and pull it over and it'll do what I want it to do. So let's see, if I look at the percentage of heads for the 40 tosses, well, there are clearly a couple of issues here. First of all, it did not include all 40 of my tosses. It only went to the 20th toss here because that's what I told it to do the first time around. So I can expand this selection. So I can say, okay, instead of going to C27, I actually want to go all the way down to this cell to C47. So I could just adjust that here, or I could redo the range. That's totally fine. But the other thing that I want to do is instead of dividing by 20, I had 40 tosses now. So let's divide by 40. And let's see what happens. Now we get 0.6, great. And then we check our last formula. We know for sure we're going to want to divide by 80, not by 20. And then, of course, we want to go down to the 87th cell here, or 87th row rather, right? And again, you can select that manually or do other things, but this is perfectly fine. So having something to sort of drag through here. And then we hit enter. And we get this value. And so we say, okay, cool. Let's kind of see what actually happened with our values and see if there was any sort of pattern here. So what did we expect to happen? Well, percentage of heads, we expect it to be, right, 50% of the times we get heads, or 0.5. And we got 0.55. So that's close, but not too bad. Percentage of heads, 0.6, this is actually farther away. So even though we had more tosses and we should have, by the law of large numbers, in theory been getting closer to 50%, right? More tosses should kind of get rid of that variability. This one actually is farther away. And then we went all the way down to 0.4375. So this is kind of telling us like, hey, we really have quite a lot of variation still with just 80 tosses. So we may want to do something where we collect data. So I'm going to go over to a blank sheet here, and I'm going to say, well, what if we did something like rand between, and we did our 0, 1, and let's say we did this for, I don't know, I'm going to go, let's see, 5, 8, 10. So 2, 4, 6, 8, 10. Okay, so I've got my 10 cells wide, and I'm going to drag this down, and I'm going to do, let's see, 10, 20. Yeah, let's do this. So this is 200 tosses that I'm doing right here. I'm going to copy and then just paste those values right back. So now I'm going to say, okay, let's count if. And I'm going to take this range and say, let's see how many ones there are. Right, so there are 105 ones. But again, if I want to think in terms of percentage, let me just divide by however many total tosses I had. So 200 tosses. So 52.5. Okay, that's pretty good. If I wanted to go even further, right, more and more tosses, we would imagine this over time we get closer and closer to the theoretical probability, which is really the goal. Not the goal, but the idea behind the law of large numbers. So we should be getting closer and closer to the theoretical probability with our empirical probabilities as we increase the number of trials. Now we saw that doesn't always happen, especially when the number of trials isn't that great. Like 80 tosses isn't a crazy amount. So sure, this percentage is a little weird, but it's not super crazy. There's not reason enough to think something's wrong with our random function or anything like that. But if this happened after 1,000 tosses, well, yeah, maybe we'd be a little suspicious. Okay, so that's the general idea. That's also, we saw the idea of sort of taking a formula and being able to drag it around. There are other versions of draggable formulas, of course, that we would want to be mindful of. and we can take a look at some of those in class, although we've also seen some of those references in the first week of classes as well.